Hi everyone and welcome to Enertech University. I'm John Pendleton. Today we're going to go over an overview of our brand new unit to Enertech. It's the air-to-water heat pump. You can see here and behind me, this is actually the AV portion or the outdoor portion, and then the indoor portion, we'll look at it here in just a moment on the other side of this wall, which will be the EM series control unit. So you may say, Enertech, why are you going to the air-to-water heat pump? You're a geothermal manufacturer. Well, we found there are occasions where not all installations have room for a ground loop, or there might be regulations that don't allow for digging into the ground or putting wells in the ground. So it takes the place of basically this is your ground loop now. There's a push for elimination of fossil fuels, and so you're going to an all-electric home, and this is a much cheaper way than using electric resistance heat or using an air-to-air heat pump. It will integrate with solar. If you have a net zero home, this is a great addition to that. If you've got a boiler replacement, you want to take out a boiler, a gas-fired boiler or oil boiler or something like that, and you want to go to all electric, this can also take the place of the boiler. We can also actually go down to negative 13 degrees and still pull heat out of the air with our variable speed unit here, the AV system. Some of the benefits of the air-to-water heat pump is in hydronic heating or in cooling, it's much more efficient, and it can transfer heat better in water than we can with ductwork or air. We can actually move as much heat in a 1-inch pipe diameter copper line as we can in a 10 by 14 duct. So it's more efficient than forced air. There's no refrigerant piping as far as in between the indoor and outdoor portions. All the refrigerant piping is here in the outdoor portion. Again, added bonus of doing 100% of your domestic water needs. We can even get down to a 2.0 COP with this unit, down to negative 13 degrees. So we're still running somewhat efficient, obviously not as well as we would at 30 or 40 degrees, but we're still getting pretty good efficiency down to negative 13 degrees. And again, we can do heating, cooling, and domestic hot water with this unit and the indoor module. Again, we can do any type of zoning needs, whether you have forced air zoning, radiant zoning, baseboards, domestic hot water generation. So zoning, it's pretty much limitless with the air-to-water unit. We can do forced air, radiant, all different kinds of zoning, so we can handle all your zoning needs. Next, we'll look at some energy efficiency comparisons of the units. Here we'll look at this chart. It'll show basically a 19 SEER heat pump, a geothermal system, and our Enertech air-to-water. The bottom line is the 19 SEER heat pump, and you can see it's going to start out somewhere around a 4.0 COP, and then once it gets down about 15 degrees, we're at that 2.0 COP. Once we get down to negative degrees outside, we're like a 1.0. So really, we're not even going to be pulling that much heat out of the air at that point either. The blue line represents the air-to-water unit, and you can see the efficiencies. We're well over a 5.0, at 50 degree outdoor air temperature, and we kind of limit out at about a 2.1 or a 2.0 COP. Then you can see the geothermal system. Of course, the geothermal system is going to be higher. We're not really too concerned about outdoor air temperatures with a geothermal unit. We're looking at water temperatures. So it stays pretty consistent. Next, we'll look at some of the capacities of the unit. You'll see we've got the AV030 and the AV060. Those are the two sizes we offer, a 2.5 ton and a 5 ton unit right now. And you'll see, it'll show you your full load COP, and I'm sure you guys probably somewhat understand that. You've seen it in our manuals before. But what you might not be familiar with in this chart is at the far right side of it, you'll see the IPLV and the NPLV. The IPLV is an integrated part load value. It's similar to a SEER rating that you would see on an air source heat pump. It's a seasonal efficiency ratio. It's commonly used to describe chiller equipment, and basically it uses a weighted formula that adjusts the efficiencies to outdoor temperatures experienced over a typical summer. And then the NPLV stands for non-standard part load value. Again, it's another commonly used in chiller applications, and it's similar to the IPLV, but it adjusts for the chilled water temperatures. This AV and EM series unit, it's not AHRI rated. They don't really have a way to rate it. So we do have a COP at 47 and 17 degree temperatures, and then the IPLV and the NPLV. The next you'll kind of see, I don't know if you guys have ever seen this chart in some of our other manuals, but it's the compressor envelope chart. It's the operating, the condensing and evaporating temperatures, which we try to keep the compressor inside this box. So you can see the smaller gray box is the standard two-stage scroll unit that you're used to seeing in our units. And then we've got the vapor injection scroll. And the vapor injection is why we can run down to negative 13 degrees. We've got a wider operating range. And we'll have more information on the vapor injection scroll later. I just kind of wanted you to see the compressor envelope and how much bigger it is compared to a two-stage scroll compressor. The next is, basically we have choices when it comes to electrification of the home or heating and cooling of the home. So here in this chart here, we're showing some more choices for electrification. And these are basically relative costs for running the equipment. So obviously electric resistance heat is going to be the highest. You can see it there, it's at $4.20. We got an air-to-air unit or a variable refrigerant flow unit, or a VRF, at $191. Our Enertech air-to-water, which is what we're going over today, is about $1.27, and that compares to a geothermal about $1. So, we're definitely at a lower cost than an air-to-air VRF or electric resistance heat. Obviously not quite as efficient as a geothermal unit would be, but if there's not possible to put a ground loop in or something like that, this is just a more efficient way to be able to heat and cool the home. So back to the AV unit here. Again, this heat pump can provide hot water for your heating needs, chilled water, and optional domestic hot water. There's two sizes available of the unit again, a 2.5 ton, which is the AV030, and the 5 ton, which is an AV060. It's single voltage here, so we only have 208, 230 volt single phase voltage on this unit at this time. It is equipped with 2 compressor heaters inside the cabinet. If you go to start this up on a cold startup, we do recommend that those compressor heaters are energized, have power to them before you do start up on the unit. It'll warm up that compressor and heat up that oil before initial startup. It'll also use those compressor heaters as if it senses cold temperatures or a cold compressor outside, it'll automatically turn those compressor heaters on. Some of the features, again, we're not using a ground loop. This air coil that's in this unit becomes your source loop, basically. There is a braze plate heat exchanger in here as well that is your load heat exchanger. So again, we're not putting any water into the ground. We're running refrigerant over the air coil and picking up or removing heat, then taking that heated refrigerant or cooled refrigerant, putting it into a braze plate heat exchanger and transferring that to the water and putting that back into your load, whether that be the domestic hot water, a chilled water coil, or your radiant floor or your forced air heating as well. Some of the available options for the configuration for your load portion of it would be a radiant heat only, so you've got some radiant floor heat, that's all you've got. We can do radiant heat with forced air hydronic heating, so you've got a hydronic air coil. You could do radiant heat with just a hydronic coil for cooling, so if you've got all your heating needs taken care of with radiant, but you still need some cooling in the home, we can definitely throw a hydronic air handler in there and do your cooling needs. We can do radiant heat with hydronic forced air heating and cooling. We can add zoning to that forced air heating and cooling. We can also take a hydronic air coil and put it over a fossil fuel system, a gas furnace, and use the dual fuel option as well. So those are some of the options that we have available right now. The AV series unit is approximately 400 pounds. It will need to be set on a solid foundation on the ground, so a concrete foundation. I wouldn't recommend setting it directly on soil or grass or even rock. I would recommend putting either some pavers down or pouring a concrete slab. The unit does need to set up out of your snow line, so if you're in Florida, you don't really necessarily need to worry about setting it up on top of a box. But if you're even here in Illinois or Indiana or anywhere in the Midwest, definitely up Minnesota, Canada, those areas, obviously you're going to have to set it up above the snow line. Again, if you're not in a snow area, then you don't have to use that base. But there is a reversing valve in the unit, and it will be energized in cooling mode, similar to the rest of our equipment. There's a couple solenoid valves that will shift and let it decide whether you're in heating mode or domestic hot water mode inside the indoor portion. There's 2 electronic expansion valves in the unit as well in the refrigerant circuit. Those EEVs have really proven to be fairly reliable. We don't have issues with them sticking or anything like that. So we are using the EEVs due to the variable speed as well. There's a variable speed outdoor fan motor. So I'm sure you may have seen those on air-to-air heat pumps, but again, it's a variable speed and super quiet. You can hardly hear it run. You almost have to walk up to it and feel the airflow coming, or look at the fan moving. It's so quiet. There is a subcooler in the unit for the vapor injection, and again, we'll get into the vapor injection in another video and explain how that all works. The subcooler is a braze plate, the real tiny braze plate for the subcooler. There's also a condensate heater in this unit. So if there's water involved, it doesn't freeze in the winter. It runs through the drain pan and keeps that water from freezing. And there's also an inverter cooler next to the compressor. The compressor has inverter controls, and we have to keep those cool. So there's an inverter cooler in there as well. The minimum outdoor temperature at which this unit will work in heating mode is negative 13 degrees. And in cooling mode, it's 32 degrees. So we'll also, when we go along, get into more of the installation, we'll talk about putting antifreeze in the water because there are water lines that run from the AV outdoor portion to your indoor unit. And we want to make sure it doesn't freeze. So we're going to have freeze protection, and we'll get into that a little bit more when we talk more about some of the install in a later video. The unit dimensions, it's 50 inches wide, it's 44.5 inches tall without the base. So you get the base on it, and it's probably going to be about as tall as I am. Now, I'm not real tall, but it'll probably be about 60 inches. And it's 24 inches deep. There is a model and serial number tag on the back side underneath the air coil on the right side of the unit. It'll have the model and the serial number there. Now the serial number, if you're not real familiar with our serial numbers, they're pretty simple. If you see that the serial number starts with an M, that means it was built in our factory in Mitchell, South Dakota. All of our units are built in Mitchell, South Dakota, so you're probably used to seeing that M on there, but that's what that stands for. The next 4 digits are the digits you really need to worry about. So let's say the serial number was at M20060012. The M, again, Mitchell, the 20 is going to be the year, so it's built in 2020. And the next is going to be your month. So the 06 would represent June. So it would be built in June of 2006. The 4 digits after that are the day it was built, and it's a resetting number, and you don't really have to worry about that. Just worry about the first 4 numbers there. The model number, the nomenclature, we'll go over the model nomenclature, and here it is. So here is the model nomenclature for the EAV outdoor unit. And so we'll cover this together here real quick. So the first digit you're going to see is going to be the brand. We only offer one brand, and that is the Enertech brand. So you're always going to have an E there. The next digit is going to be the type of unit, and this is an A, which is an air-to-water unit. The third digit is the staging. So this is a variable speed unit, so we're going to use the V for the variable speed. The next three digits are the size of the unit or the unit capacity. We only have two available. We have the 030 or the 060. So again, that's just the capacity in BTUs. The next digit is the revision, and this is more for engineering, tech support, so we know what revision, and if something major has changed inside the unit, it'll kind of reference it by this number. Obviously, we're on the first revision right now, so you're just going to have an A there. The next digit is the voltage code, and we have a 1 for residential, and we don't have the commercial available yet, but at some point we may. So you may see a 0 listed there for a commercial unit. The next three digits, the A's, the AAA, those are all for future use. If we were to add, something to the unit, this is where we would address that. The next, you'll see a B notated here, and that's the load heat exchanger, which it's a braze plate and will always be a braze plate. So you have a B there. The next is your source heat exchanger, and we're using a tube and fin air coil for our source heat exchanger. And then the next two digits, the S and the S, those are the standard stock factory options. So those really won't change at this point in time. If we were to add something else, those two digits may change. But for now, those will stay as the SS. Some installation notes on the AV unit is don't install it where there could be combustible gas coming out. If you've got a gas furnace inside, don't set it right next to the vent of it. We don't want that combustible gases getting on the air coil that could eat away at the fins. Don't put it in a location where it's in direct exposure to any type of oils or steam, chlorine, salt water, chemical sprays, sulfide gases, or locations with machinery that could cause some high-frequency harmonics. If you have a location where there's large amounts of snow drift or snow accumulation, we wouldn't recommend that. Chimney smoke. We don't want chimney smoke coming directly off of this. You got a wood-fired furnace that you're using to help heat the home. Hopefully it's not putting the chimney smoke directly onto this unit, as it can affect the components along with the air coil. Be sure the back of the unit is facing towards the home or the building, and it is protected from direct wind, as that could affect our defrost function, because it does have a defrost initiated on this unit, and we'll cover the defrost at a later time as well. Again, it needs to be set on a solid base. That's very important. Otherwise, it's going to start to lean. There is a compressor in here, and so we need to make sure that this unit is somewhat level all the time, just like any geothermal unit or air source heat pump. Again, the lower edge of the unit must be above the snow line and should not be positioned next to a noise-sensitive room. So if you've got a bedroom, a nursery, something like that, I'm not saying this unit's loud, but you could hear maybe some vibration from the water pipes running through the wall. And so we don't want it sitting next to any noise-sensitive area. Again, the back of the unit needs to be protected from direct wind, which will affect the defrost function. And again, the air coil side should face the home. If snow from the roof could slip and fall on top of the unit, you may want to build an overhang or some kind of roof cover for the unit. Again, do not place the unit directly on the lawn or the grass. Make sure we're putting a base down for the unit. There is a condensate drain on the back side of the unit, It does not require a trap, and we want you to keep that drain line as short as possible as well. And I would recommend directing it away from the home. That way it doesn't cause any soil problems against the home or run down against the foundation and leak into their basement or something like that. Try to direct it away from the home. The distance between the building and the unit itself needs to be at least 14 inches, and clearance above the unit needs to be about 40 inches. So if you're putting a roof on it, make sure we got about a 40-inch clearance. There are times when we're going to have to take this top off the unit, so we're going to have a little bit of clearance to be able to do that. The clearance on the front of the unit needs to be 40 inches, and we need to make sure that there's not something sitting here in front of the unit where we could actually recirculate the output air right back into the back of the air coil and recirculate the same air. It's going to cause problems with the refrigerant circuit. The controls are on the right side if you're facing the unit. The controls will be over here, kind of like behind this sticker we've got. In order to get to the controls, you will have to take off 2 screws on the top, on the side, and lift this side up. And there's 2 screws on the side door, and you'll take those off and slide the door off, and then this can set back down and you can get to the controls. We'll get to the control side in another video, and I'll show you how to take the door off then. The water line connections, the unit will ship with 2 stainless steel braided hoses that will thread on to the water lines on the back side. Make sure when you're tightening those that you're using a double wrench kind of configuration where one's for backup and one's for tightening, because you can cause that copper that's stubbed out of the unit to strip out and then leak. So make sure you're always backing up the system. Again, those water line connection hoses are supplied with the unit. And we do recommend that you insulate the water lines as well with a 3/4 inch insulation so that they don't condensate all over the place. The water lines will need to be vented from air once you do fill it up with water. And there is a vent nipple on the stubbed out water line on the back side of the unit. So you can vent air out that way. If for some reason, once you get the unit started back up, you do hear some bubbling or gurgling, you can try to vent it, the rest of it out of there. If you can't get it all out, then there are flush blocks inside the indoor portion, and you can flush it out with a flush cart, which is very possible that you will have to use a flush cart. Make sure that you do open up the vent screw inside the indoor portion on the pump and remove any kind of air that's in the pump so we can lubricate that shaft that's in the pump. So this is the EM series portion, or the indoor portion of the unit, along with the, if you're going to do your domestic hot water, here's the Turbo Max tank as well. So this EM unit here is 54 inches tall, 28 inches wide, and 14 inches deep. There is a model and serial number tag on the left side down below near the water line down there. So that's going to be your model and serial number tag down in the lower left portion of the unit. So here is the nomenclature for the indoor control module for the AV system. The first digit, again, it's going to be an E for the brand. Enertech brand is the only brand we offer in this. The next digit is going to be the type, and it's an indoor module for the air-to-water unit. So we're just going to use an M for that designation. The third digit is going to be your backup heat option. So if you're going to use dual fuel with a boiler backup, then you would have a D there, and so there's no internal heater on the indoor module. If there is an E designated there, then you will have the internal electric immersion heater in the indoor module. The next is the unit capacity, 4, 5, and 6 are unit capacity. The module doesn't have capacity, so it's not going to be rated in BTUs, so you'll just have 3 zeros. The 7th digit is the revision code, again, more for engineering or tech support, and we're on current revision A. So right now, just have an A there. The next is your voltage code. Again, 1 is for a 208, 230 volt residential unit. And in the future, we will have a 0 for a 208, 230 commercial unit. Then the number 9, 10, and 11 digits, those are all going to be, the first number 9 is for a future use for the models. So we're just going to leave an A there. And then the 10th option will be for our controls. Right now, we do not have an option. In the future, we will have some connected controls, so that may change, maybe to a C or something other than an A. But right now, there is no other option, so you're just going to have an A there. And then the final digit, number 11, there's no option available right now. We may use that for future use. So you will just have an A there. So that's the nomenclature for the indoor control module. So you can see in this little chart here, these are the two TurboMax tanks that we offer. So we have the TurboMax 45-gallon tank with our item number 01P001-02NN. And then also the TurboMax 65-gallon tank, which is Enertech part number 01P002-02NN. This unit, it weighs about 200 pounds, and it will hang on the wall with a bracket. This is the wall bracket here. It'll sit on the wall actually like this. And these two screw holes, once you set the unit onto it, there'll be a couple screws you can put in here so it won't slide or anything like that. Now, as you can see here, we do have it sitting on the floor, and we can set it on the floor. That's not a problem with that, but it still needs that wall bracket. We don't want it to fall this way if somebody were to grab it. We want it secured to the wall so it doesn't fall. But you can mount it on the wall above the floor level, or you can set it on the floor and then attach it to the wall. Either way, it's not really going to matter too much to us. Let's go ahead and open this unit up, and we'll look at some of the components inside the unit. Now, there's 3 screws on the unit. One in the middle down low, and then 2 in the middle of the panel on the sides. Then you can just lift up a little bit and drop it down. And you can see there's a couple little tabs here that will slide into the cabinet itself to kind of secure it in. So we can slide this out of our way. So we have backup heat. We kind of talked about that a little bit. This gray bar in here that's insulated, this is your 9 kilowatt heater. There's also a manual reset on the back side of it that if it overheats, it'll trip that limit and it'll knock out power to the whole unit. So it doesn't want it to run if there's some reason that this overamps or it's not getting water flow. So here is the HMI, and it is basically the human-machine interface. And this is where we're going to set up our flows, temperatures, things like that. This is the main control module for controlling everything that's in this box. If you're going to use a domestic hot water feature, again, we have to use this TurboMax tank. Again, we have it in a 45-gallon and a 65-gallon tank. There's no other tank that we can use. It has to be the TurboMax tank. We do have a chart in the manual that'll help you figure out if you had a gas water heater before, and it was a 100-gallon tank, what size tank you should get. Because this tank here basically is the load water from the unit is the bulk water inside of the tank. And then you have your domestic hot water that runs through the middle of that tank and picks up the heat from the load water. So it works as like a on-demand water heater or an instant water heater, or however you want to call it. But So we don't necessarily need to size it like we would a standard water heater. We do have a chart in the manual that'll help you figure that out. How many people are in the home, what size tank was there in the past, so we can make sure you get the right size tank. There's insulated flush blocks right here, so you can flush the unit itself. They're already going to be installed, double O-ring, you can hook your flush cart right to it. There's an internal bypass valve, so if you don't have proper water flow, the extra water flow that you need to get proper water flow will be through this bypass valve. Now this bypass valve will be adjusted from the factory, but it will need to be checked and possibly adjusted in the field as well. If you've dealt with our variable speed water to water unit, you'll know that we had minimum water flow requirements. Well, that's the same thing with this. And if you have a small zone or something like that and you can't get that flow that we need, then that's where this bypass valve is going to come in handy. There is an expansion tank in the unit down at the bottom. I'm not exactly sure if this is the one we're going to stick with or not, so I'm not going to tell you a brand or anything. But when we're doing the domestic hot water, we've got the expansion tank. The EM series indoor module is designed for only indoor applications. It needs to be stored in an area that's always going to remain between 55 and 95 degrees, and we don't get high humidity levels either. So I wouldn't stick this in a crawl space, or in an unconditioned garage. It really needs to sit somewhere that's somewhat conditioned and out of the weather. Also, make sure when you're installing this that where you install it, that there's no connections that you're going to have to remove to get the door off or to service the equipment. If you need to replace that expansion tank sooner or later, we don't want water lines coming right into the front of the cabinet where we can't get to that expansion tank to remove it. We have 2 water lines on the side of the unit here. We've got your out to your hydronic loop field and your out for your hot water tank. So this is your load to your radiant or your forced air heating or cooling. This is going to be the load for that, and this one's going to be the load for your domestic hot water. The water lines on the other side of the unit are going to come down a little bit more towards the bottom of the unit. We've got your radiant coming in, as well as your supplying to your Turbo Max tank here as well. And then we've got water line connections for the domestic, for the home, you're in and you're out, down to bottom and up on top here of the Turbo Max tank. So as you can see here on this wiring diagram, the voltage is going to come into this power distribution block here on the right side of the wiring diagram. So this is where your line voltage will come into the unit. We do have a variable speed pump in here. Make sure that you've got a little yellow tag on it. If you remove that yellow tag, there's a screw behind it. You can open up that screw, bleed some air, and make sure that shaft is flooded. That shaft is liquid cooled. So we got to make sure that it's always got fluid in it. Again, these are some of the control boards. Your low voltage wiring is going to come in here. We have some relays for deciding your staging for your electric heat. But basically, again, this is all your controls. You've got a solenoid valve here, as well as one up a little higher. And these will open and close depending on what mode you're in, whether you're in hydronic heating mode or whether you're in domestic hot water heating mode. We also have a box over these low voltage control wiring. So you have to remove that to get to the controls, and that'll just go right back on. We'll get into a little bit more of that in a later video dealing with more of the controls and things like that. So water lines from the outdoor portion to the indoor portion, they also come in on the right side, but way down at the very bottom, down below. And there'll be 1-inch copper lines as well. The water lines from the outdoor portion of the unit, from the AV, will come down in the lower right. You can see them down here. This is the outdoor, coming in from the outdoor and out from the outdoor. Now, inside the unit as well, I forgot to mention that on those water lines there is a strainer, a number 40Y mesh strainer in there. installed from the factory. If you ever do have flow problems, make sure you do check that Y strainer that's inside this EM series unit. So that concludes the overview of the EM AV series air to water heat pump. Thanks for watching.